Imagine a planet that was once not dry, not dead, not red, but blue and green. With clouds in the sky, rain tapping against rocks, and deep oceans roaring across its surface. This is not a fairy tale. This is Mars. This is how scientists now envision it, piecing together fragments discovered over recent decades. In the 1970s, when orbital images of Mars first reached scientists, their astonishment was undeniable. They saw not just craters and voids. They saw traces of something familiar. Ancient rivers, deltas, lakes, even shorelines. These formations were too orderly, too similar to what we see on Earth. Valles Marineris, one of the largest canyon systems in the solar system, stretches over 4,000 kilometers. That's 10 times longer than the Grand Canyon. Some scientists believe it may have been shaped not only by tectonic activity but also by vast flows of water in the distant past. Martian riverbeds are not rare. There are dozens, possibly hundreds. They branch out like Earth's drainage systems. Some run for hundreds of kilometers, an extraordinary length for any planet. Entire regions, such as the Argyre Basin or Jezero Crater, show structures that closely resemble deltas. In 2021, the Perseverance rover landed in Jezero Crater, not by coincidence. Analysis of satellite imagery suggests there was once a lake there. And on Earth, deltas often preserve evidence of life. But how could so much water have existed on a planet that now has an atmosphere 100 times thinner than Earth's, offers no protection from solar radiation, and has an average temperature of -60 degrees Celsius? The answer: the atmosphere used to be different. Billions of years ago, Mars had a denser atmosphere, probably warmer. It may have been filled with greenhouse gases that trapped heat and allowed water to remain liquid. It may also have had a magnetic field, a shield protecting it from the ravages of solar wind. But over time, that shield vanished. And with it, the protection. The atmosphere began to dissipate. Water evaporated or froze, and the planet began to die. Still, some scientists believe not all water is gone. Some may be hiding underground as frozen reservoirs or perhaps as salty, liquid water trapped beneath the surface. In 2018, using data from the Italian radar instrument MARSIS, researchers discovered what may be a subsurface lake beneath the planet's southern polar ice cap. The temperature is too cold for regular water, but the presence of salts could lower the freezing point. This means liquid water might still exist, and with it a chance for life. Water is not just a scientific fact. It is a symbol. The traces of water on Mars are traces of a possible past. A testament that this planet was once different. Softer. More alive. And when we look at the dried riverbeds in the forgotten valleys, we don't just see geology. We see the ghosts of history. A silent reminder that even the driest desert might have once been an ocean. And even the deadest world might have once breathed. Today, Mars is a defenseless planet. Its atmosphere is thin, fragile like a veil. It cannot retain heat. It cannot shield the surface from harmful solar radiation. The sun strikes the ground mercilessly, turning the surface into a scorched wasteland. But why? Once, things were different. Mars once had an atmosphere much thicker, warmer, richer. The planet could sustain liquid water. It may have had a climate resembling early Earth. To understand what went wrong, we need to look deeper, literally beneath the planet's surface. Specifically, into its core. Early in its history, Mars had what scientists call a dynamo, a rotating liquid iron core that generated a magnetic field. This field was a protective cocoon. Just like Earth's, it shielded the atmosphere from the solar wind, a stream of charged particles that can strip the air from unprotected planets. But around 4 billion years ago, something changed. Mars's core, for some reason, cooled or lost its motion. The magnetic field began to fade, and then it disappeared. That's when the sun began to slowly undress the planet. Charged particles from the solar wind bombarded the atmosphere relentlessly. The molecules of gas, especially light ones, like hydrogen and helium, escaped into space. Surface pressure dropped. The greenhouse effect weakened. Temperatures plummeted. Water began to evaporate, and what remained froze into the ground, or the polar caps. Today, the surface pressure on Mars is only about 0.6% of Earth's samba. That's not enough for liquid water to survive. It simply boils away and instantly turns to vapor. Even ice sublimates, skipping the liquid phase. Without a magnetic field, Mars became an open battlefield. Every day, every hour, its surface is struck by cosmic radiation. This kills any potential for life and makes the idea of colonization extraordinarily difficult. But why did the core shut down? There are theories. One suggests Mars is simply too small. The planet's mass is not sufficient to sustain long-term movement of liquid iron in the core. Earth, being larger, still has an active core today. Another theory points to a catastrophic event. A giant collision, a planetary-scale impact. Perhaps a large asteroid or protoplanet struck Mars, altering its internal structure. On the opposite side of the planet from where such an impact may have occurred, we see strange geological anomalies, possibly scars from that ancient disaster. Whatever the cause, the protection was lost. And that changed everything. Mars didn't die overnight. It was a slow, invisible death. Each day a little less atmosphere. Each solar storm another blow. And millions of years later, we are left with a red, dry, dead world. But not entirely dead. Its past is preserved in dust layers, in frozen water, in stone. Which means there's a chance to understand how it all began. And how it might one day begin again. Imagine an ocean. Not on Earth, but on Mars. Vast, deep, with waves crashing onto red shores. An ocean that may have once covered a third of the planet. An ocean where life might have first emerged. This isn't fantasy. It's one of the most compelling theories about the red planet's past. In Mars's northern hemisphere lies a vast lowland region known as Arabia Terra and Vastitas Borealis. It is almost perfectly flat, with only slight variations in elevation. And crucially, it lies well below the level of the rest of the planet. Exactly what we'd expect to find if this area had once held a sea. In 2015, scientists analyzing rover and orbital data noticed something strange. Minerals that usually form in water like clays and sulfates were found exactly along the potential ancient shoreline. Everything pointed to the existence of a massive ocean. By some estimates, Mars's ocean may have held up to 17 million cubic kilometers of water. That's nearly half the volume of Earth's Atlantic Ocean. There are even coastlines stretching for thousands of kilometers, with bends resembling Earth's bays, gulfs, and estuaries. But the question arises, where did it go? The ocean may have evaporated as the atmosphere began to disappear. Water rose into the air as vapor and escaped into space. But that's only part of the story. Studies of hydrogen isotopes on Mars show that lighter atoms, ordinary hydrogen, escaped, leaving behind the heavier isotope deuterium. Today, the deuterium to hydrogen ratio on Mars is 5-6 times higher than on Earth. This points to enormous water loss over billions of years. Another portion of the water may have simply frozen into the soil. Deep beneath the surface, remnants of ancient oceans may still exist, now frozen forever. In some areas of Mars, when dust is blown away, patches of ice appear, possibly remnants of that hidden ocean. But there's still a mystery. How could an ocean be stable in Mars's gravity and atmosphere? This leads us to a bolder idea that Mars once had a warm and stable climate for a long time. Perhaps there were clouds, rains, even seasonal cycles. Or maybe there was something else. Something we don't yet understand. Because if there was an ocean, there may have been life. Perhaps deep within the Martian sea, the first cells formed. Perhaps they didn't all die. Perhaps something still waits in underground reservoirs, in icy caves, or at the bottom of long dry lakes. The ocean is gone, but the idea of it still stirs the imagination. Because it means Mars wasn't always dead. It may have once been young, warm, and alive. What if we're not alone? This question has haunted humanity since ancient times. And when we talk about life beyond Earth, Mars is perhaps the first candidate. Not just because it's close, but because it's the most similar. It once had water. It had warmth. Perhaps it had an atmosphere like ours. And if that's true, could life have emerged there? We're looking for the traces, carefully studying the soil, analyzing samples, exploring craters that once held lakes, monitoring methane in the atmosphere. Methane is key. On Earth, most methane has a biological origin. It's produced by microorganisms in swamps, in soil, even in the stomachs of animals. And strangely, Mars has methane too. Its levels fluctuate seasonally. It disappears, then reappears. But what's producing it? There are two possibilities. First, geological. Methane can form when water reacts with certain rocks under pressure. This doesn't require life. But the second is biological. That would mean something is alive. Microbes, bacteria. Life beneath the surface in caves, under the soil, hidden from radiation. We don't have a definitive answer, but we're searching, and every mission brings us closer. In 2021, the rover Perseverance began exploring the Jezero crater, once a lake, with a river delta. It's a perfect place to preserve signs of life. Clay, sediment, layered deposits, all of it could have sealed in organic material. What we're hoping for are biosignatures. Molecules that, on Earth, are associated with life. Even if life itself is long gone, its traces might remain. Some scientists believe signs of life have already been found. In Martian meteorites that fell to Earth, structures resembling bacteria were discovered. It's not proven. It's not a fact. But it's another clue. There's also a hypothesis that life on Earth came from Mars. It sounds like science fiction, but it has a scientific basis. If life emerged first on Mars, and then a massive impact ejected rocks into space, and if those rocks reached Earth, they could have brought microbes with them. Life that didn't originate here, but arrived from there. Perhaps we are the Martians. Sounds crazy? Yes. But in science, it's not only the answers that matter, it's the questions we dare to ask. And the biggest question of all is still open. Are we alone in the universe? Mars is the first place where we seek the answer. Every living planet has a shield. Invisible, yet vital. A magnetic field. Protects against cosmic radiation. Against the solar wind. It holds the atmosphere in place, preserves water, and makes life possible. Earth has one. Mars does not. Once, Mars had its own magnetic field, as strong as Earth's. But then it vanished. Why? One hypothesis is this: Mars's inner core cooled. On Earth, the movement of molten iron in the core creates a dynamo effect. That's the engine of the magnetic field. On Mars, that engine stopped. And when the magnetic shield disappeared, the solar wind began stripping away the atmosphere. Drop by drop, molecule by molecule, over billions of years. Today, Mars's atmosphere is extremely thin, less than 1% of Earth's arcs. And it's the loss of its magnetic field that turned the planet cold, dry, and dead. But if we want to bring life back to Mars, Can we restore its magnetic field? The idea sounds wild, but it's being discussed not by sci-fi writers, but by scientists at NASA and ESA. One proposal: place a giant magnet near Mars, in the Lagrange point L, one between Mars and the Sun. There, the magnet would create an artificial shield, protecting the atmosphere from solar wind. It wouldn't regenerate Mars's own field, but it could stop further loss. Another idea: heat up the Martian core. How? For instance, through a series of nuclear detonations at the planet's center, theoretically. This might restart the dynamo, but the risks are immense. Other concepts include plasma generators, enormous satellite mirrors, or even a technosphere, an artificial shell generating a magnetic field around the planet. Today, this sounds like science fiction. But once, so did walking on the moon. Because if we ever want to live on Mars, we must do more than build domes. We must give it back its heart. A magnetic heart, pulsing with invisible rhythm. The rhythm of a living world. Imagine a planet where there's no air to breathe, where every breath is technology, where life is impossible without a spacesuit. That's Mars. Its atmosphere is a whisper-thin veil of carbon dioxide. Pressure 100 times lower than on Earth. Oxygen almost non-existent. Temperature? On average, -60 degrees Celsius. At night, even lower. Lethal, cold. But if we ever want to live there, the atmosphere must change. We must turn Mars into a second Earth. This process is called terraforming. The idea to change the climate, pressure, and atmosphere composition so the planet becomes habitable. How? First, we need to heat the planet. Once temperatures rise, frozen CO at the poles will start to evaporate. This will trigger a greenhouse effect, amplifying the warming. Gradually, pressure will rise, and the atmosphere will thicken. Methods? Orbital mirrors to focus sunlight on the polar ice caps. Mass production of greenhouse gases like perfluorocarbons, far stronger than CO. Bombarding Mars with ammonia-rich asteroids to release additional gases. Giant greenhouses where plants produce oxygen. It sounds like a civilization-scale megaproject. And it is. But even under optimistic estimates, full transformation of Mars's atmosphere would take thousands of years. And unimaginable resources. There's another view. Don't change Mars, change ourselves. Live in sealed domes. Edit human DNA for adaptation. This isn't a planet for humans. We must become Martians. But what if we could? What if we created a Martian dawn, where the air is clear and the sky blue? What if one day, a child steps outside without a suit, feels the wind, a real wind, not from a machine, and breathes real air? This is not a dream. It's a question of technology, time, and will. Without water, there is no life. That's the rule. No exceptions. All known life forms depend on it. And when we search for life in the universe, we search for water. Mars had it. A lot of it. Rivers, lakes, even oceans. But where did it go? Today, Mars is a dry desert. Temperatures are too low for liquid water. It either freezes or evaporates. And the atmosphere is too thin to hold it. But that doesn't mean the water is gone. It's still there, beneath the surface, in the form of ice. Satellites detect massive deposits of frozen water near the poles. In some regions, even closer to the equator. In 2018, the Mars Express radar detected something incredible. Beneath the southern pole, there's a lake. Liquid. Salty. Possibly stable. This discovery challenged our idea of a dry Mars and gave new hope. So how do we bring water back to the surface? One option: heat the planet. Rising temperatures will cause ice to melt. Temporary rivers, lakes, and atmospheric moisture could appear. Another option: use local ice. Melt it inside enclosed colonies. Use it for drinking, growing plants, generating steam. A third option: import water from asteroids or moons. But that's expensive and complex. There's one more idea: create a cycle. Vapor, clouds, rain. An artificial weather system. If we can start a water cycle, it would be revolutionary. But the main question remains: can we restore water, not just as a resource, but as a living environment? Because water isn't just H2O. It's the liquid cradle of biology, the memory of a planet, and maybe the key to its future. At first glance, Mars appears to have just 2 moons, small, unremarkable, and almost pitiful by cosmic standards. Phobos and Deimos, their names mean fear and terror in Greek, and those names seem eerily appropriate. Both moons have irregular, potato-like shapes, their surfaces marked by numerous craters, cracks, and a dark, porous regolith that absorbs light instead of reflecting it as if they were born from shadow. Unlike large, spherical moons like our own, these appear more like debris fragments of something older or something else entirely. So, what makes them so mysterious? First of all, their size. Phobos is only about 22 kilometers in diameter, and Deimos is even smaller, around 12 kilometers. These are not typical planetary moons, especially not for a world that may once have had oceans and a thick atmosphere. They resemble asteroids more than satellites, and that resemblance might not be accidental. One popular hypothesis suggests that Phobos and Deimos didn't form alongside Mars, but were captured from the asteroid belt, pulled into orbit by the planet's gravity billions of years ago. But this theory leaves gaps. Their nearly circular orbits, perfectly aligned with Mars's equator, are strange for captured objects too perfect, almost suspiciously so. This leads to an alternative idea. Perhaps they are the remnants of a colossal collision debris from an ancient, shattered moon, reassembled by gravity into the forms we see today. Yet some theories go even further. Phobos, for example, orbits Mars incredibly fast, completing a full revolution in less than 8 hours, which means it moves faster than Mars itself rotates. Because of this, it's slowly but inevitably spiraling toward the planet, and in 30 to 50 million years, it will be torn apart by tidal forces and crash into the surface, or possibly form a ring around Mars, much like Saturn's. But there's an even stranger idea. In the 1960s, Soviet radar studies of Phobos returned unexpected results, anomalies that led some researchers to speculate, what if Phobos is hollow inside? This fueled a radical theory that it might be artificial. Yes, it sounds like science fiction, and the mainstream scientific community largely rejects it. But the truth is, we still don't have a definitive explanation for the origins of Mars's moons. Until we send missions to study them up close, perhaps to return samples, or even land Phobos and Deimos, will remain enigmatic shadows in Mars's sky, quietly reminding us that in the cosmos, very little is ever as it seems. Could Mars once have been home to intelligent life? This question has haunted scientists since the 19th century, when astronomers peered through early telescopes and saw what appeared to be canals, straight lines etched across the red planet's surface. One of the most vocal proponents of this idea, astronomer Percival Lowell, was convinced. These were artificial structures, built by a dying civilization to irrigate their arid world. Though later disproven, the theory left a deep mark on human imagination. Mars became a planet of mystery, a world where more than just rocks and dust might have existed. Today, we know the canals were an optical illusion, a trick of imperfect lenses and eager minds. And yet, the question remains. In fact, it has only deepened. Because we now see that Mars was once warmer. It had liquid water. It may have had a thicker atmosphere, a magnetic field, and possibly the right conditions for life. And if those conditions existed billions of years ago, why couldn't life simple or even complex have emerged? Some researchers believe microorganisms may have evolved there. Others suggest life might have been delivered via meteorites, perhaps from Earth or even another planet, in line with the theory of panspermia. There are also more speculative, but no less fascinating ideas. Certain geological formations on Mars resemble shapes that seem oddly familiar. The most famous of these is the so-called face on Mars. Discovered by Viking 1 in 1976 on the Cydonia Plateau, it appeared to be a giant humanoid face carved in stone. NASA later explained the phenomenon as a play of shadows and light, a natural landform that looked very different in higher resolution images. But for some alternative theorists, it became a symbol. What if Mars once held something more? A city? A temple? The remnants of a vanished civilization? And here's where things get truly intriguing. Science fiction and science sometimes touch. Because even if there were no cities, no engineers, no monuments, perhaps there was life. Perhaps there still is. Modern missions like Perseverance are searching for biosignatures, ancient sediments, traces of organics, possible microbial textures. The question isn't whether Martians had antennas. It's whether Mars was ever alive. And if so, what happened to it? In other words, could the lost civilization of Mars be more than a myth? Maybe the answer is just beneath the red dust. Once upon a time, Mars may have looked much like early Earth, warmer, with an atmosphere, rivers, lakes, perhaps even an ocean. But something went wrong. Today, it's a cold, dead desert with no magnetic field and a thin, fragile atmosphere that offers no protection from space radiation. What happened? Why did Mars lose it all? One of the leading theories points to the loss of its magnetic field. On Earth, the planet's molten iron core powers a magnetic shield, the magnetosphere that protects our atmosphere from the solar wind. Mars, according to current data, lost its magnetic field about 4 billion years ago. And once it did, the atmosphere began to slowly leak into space. The solar wind, a stream of charged particles, began stripping Mars of its atmosphere, atom by atom. Without protection, the planet couldn't retain its gaseous shell. And without atmosphere, the greenhouse effect vanished. Water disappeared first from the surface, and then perhaps even from underground reserves. This process wasn't sudden, but its outcome was devastating. That's why Mars is what it is today, a ghost planet. What's fascinating is that we can observe these changes not only through telescopes, but via missions like MAVEN, which studies atmospheric loss. Its data reveals that Mars is still losing part of itself every day. Every second, a spark drifts away, a breath of a dying world. But what if this wasn't just a natural disaster? Some speculative theories suggest, what if Mars didn't lose everything by chance? What if there was external influence? Or even a technological catastrophe? Will we ever know the truth? Maybe. But to answer that question, we'll need more than just exploration. We'll need to understand ourselves. Because maybe what happened to Mars could happen here too. Scientific models tell us Mars lost its atmosphere due to natural processes, internal cooling, the end of geological activity, and the subsequent loss of its magnetic field. Then came the solar wind, gradually stripping the planet's atmosphere and depleting its water. It all makes sense, but there are details that keep some researchers up at night. On the surface of Mars, there are regions where radiation levels are significantly higher than elsewhere. One such place is Utopia Planitia. In this area, researchers have detected an unusual excess of xenon-129, an isotope that, according to some interpretations, may be evidence of a nuclear explosion. NASA scientists acknowledge this as an anomaly, Most attribute it to natural processes, but not everyone agrees. Physicist Dr. John Brandenburg, who studied the Martian atmosphere, proposed a bold hypothesis. What if nuclear explosions occurred on Mars not naturally, but artificially, as the result of a war between ancient civilizations? This theory sounds like science fiction, and maybe it is. But it raises questions that still have no clear answers. Could the high radiation levels be the result of a localized nuclear event? Are there other signs, not just chemical, but structural? Could something built lie buried beneath the dust? We have no solid proof, but we have possibilities, and they, when paired with science, drive exploration forward. Maybe we'll never know the full truth. But the very idea that Mars might have suffered a man-made cataclysm changes how we look at the planet's past. And if it happened there, who's to say it can't happen here? When we look at Mars today, we see a dead world, cold, unprotected, cloaked in dust. But will it always be this way? Is it possible that Mars could live again? Among scientists and visionaries, a dream has long taken root to transform Mars into a second Earth. This process is called terraforming. The goal is to alter the planet's atmosphere, temperature, and ultimately its ecosystem to make it suitable for human life. It sounds ambitious, maybe even utopian, but what if it's more than just fantasy? What if we truly can bring life back to a world that once lost it? One proposed method is to trigger a greenhouse effect, for instance, by releasing gases such as perfluorocarbons, which trap heat. This could gradually warm the surface and unlock frozen reserves of water and carbon dioxide. Another idea: launch massive orbital mirrors that reflect sunlight directly onto Mars's poles, melting the ice caps. And a bolder proposal: nuclear explosions to rapidly melt the polar ice. Elon Musk summed this up in 2 words: nuke Mars. But these are not just technical questions. They're ethical, philosophical, and ecological ones. Mars is its own world. Though lifeless, it is unique. And if we someday find microbial life there, do we have the right to change it? Terraforming would also demand resources, time, and technologies we don't yet possess. And the biggest question of all: why? To escape Earth? Or to prove we can build, not just destroy? Perhaps terraforming Mars is not only about the planet. It's a test of humanity, not a story of conquest, but of renewal, maybe even redemption. Imagine this: humans waking up beneath domes that shield them from the Martian cold. They grow plants in greenhouses under artificial lights, walk in spacesuits between modular habitats, and outside red dust, a dead desert, and a tiny Sunday hovering on the horizon. This isn't a scene from a sci-fi movie. It's a potential vision of our future. But how realistic is it? Companies like SpaceX already have long-term plans for Martian colonization. Their goal is to build a self-sustaining human settlement, one that could survive even if catastrophe strikes Earth. Elon Musk speaks of hundreds of starships, thousands of pioneers, and eventually, a million-strong Martian civilization. But Mars isn't welcoming us with open arms. The atmosphere is too thin to breathe. Radiation is lethal. Temperatures are extreme. Even the simplest tasks, building shelters, producing water, growing food, are enormous challenges. Psychologically, it's a different world, too. Confined living spaces, constant isolation, gravity only 1/3 of Earth's. Mars may become not just a second home, but a test of our mental and physical resilience. But does that mean we should give up? Absolutely not. In fact, the drive to colonize Mars reflects who we are. We are explorers. We are boundary breakers. And even if the first settlements are harsh, even if much goes wrong with each generation, we'll come closer to calling Mars home. Perhaps in the distant future, children will be born not on Earth, but beneath the crimson sky. And by then the question, can Mars become a second home, will no longer need asking. It simply will be. When we talk about colonizing Mars, the conversation often revolves around technology, logistics, rockets, energy systems, but a deeper question lingers between the lines. Why are we so eager to leave? We often hear the argument, Earth is in danger, climate change, wars, overpopulation. We need a backup plan. And Mars appears as the emergency exit, cold, but untouched, an escape. But is that the right path? Do we have the right to abandon the planet we've already damaged? Shouldn't we first learn to protect our home before seeking a new one? Colonizing Mars isn't just a technical challenge, it's an ethical one. If we bring with us the same habits, the same conflicts, the same disregard for nature, will this new world truly be any better? Mars is an opportunity, but only if we become different ourselves. Perhaps the first Martian settlements will teach us to value every breath of air, every drop of water. Perhaps there, on a distant world, we will remember how rare and priceless Earth truly is, and that running from problems isn't always the solution. Mars may mark the beginning of a new chapter for humanity, but not as Earth's replacement, as a reminder of its worth. Mars is silent. It sends no signals, offers no clear answers. But look closely and you'll see. This planet is hiding something. At first glance, Mars is just a red ball, covered in rock and dust. But the more we study it, the more questions emerge. Some of them uncomfortable, even unsettling. Why did a planet that once had a magnetic field and possibly rivers lose it all? What caused this dramatic death of a world that may once have thrived? And what lies beneath the Martian surface? Some orbital images show strange formations, geometric shapes that seem too perfect to be natural. Are they just tricks of light and shadow, or something more? Thousands of enthusiasts still debate. Could intelligent beings once have lived on Mars long before Earth's first civilizations? The most famous example is the so-called face on Mars in the Cydonia region. In 1976, a satellite image appeared to show a massive stone face with carved features. Later, higher-resolution images revealed it to be just a hill. But is it really that simple? Even if it's an illusion, the fact that we so desperately search for familiar shapes on a distant world reveals something deeper. We want to find life. We want to know we're not alone. And maybe Mars isn't just another planet, but a missing piece in a much larger cosmic story. There are even theories suggesting Martian life is not just speculation, that it once existed and may have left behind clues. These questions won't go away. And as we solve one mystery, 10 more arise. Mars is silent, but its silence speaks louder than 1,000 words. When we look at the surface of Mars, it appears wild, chaotic, broken. But sometimes, something stands out: structures that look suspiciously organized. Mountains shaped like pyramids. Plateaus with sharp, angular edges. Straight lines stretching for kilometers. All of it raises a simple yet unsettling question. Was this shaped by nature or by something else? One such place is the Cydonia region, the same area where the face on Mars was found. But nearby are even stranger formations, symmetrical hills, which some researchers have dubbed Martian pyramids. They form geometric shapes, pentagons, triangles. Coincidence? Maybe. But some believe these are remnants of a lost civilization. Similar anomalies exist in other regions. The Elysium Planitia, the Valles Marineris, craters with perfectly round islands in the center. Each formation is like a whisper from the past, raising questions, giving no answers. Skeptics say it's pareidolia, the brain's tendency to see familiar patterns where there are none. And yes, our minds are wired to find order in randomness. But what if some of those patterns are real? Perhaps Mars was not only alive, but civilized. Perhaps a great catastrophe, environmental, geological, or even a war wiped it out. These theories are bold, even crazy, but history has taught us what once sounded absurd can become accepted science. For now, all we can do is photograph, analyze, wonder. The mysterious structures remain, staring back from the deep silence of time. And maybe they're waiting for us to realize there was more to Mars than dust and stone. The more we learn about Mars, the more we notice it resembles us. Not like Venus, hot, toxic, wrapped in acidic clouds. And not like Jupiter, a gas giant with no solid surface. Mars feels familiar, like a distant relative who met a different fate. Once, it had an atmosphere, maybe clouds, rain, even oceans. Its axial tilt is similar to Earth's meaning seasons. Its day is nearly the same as ours, just 37 minutes longer. So, Mars could have had rhythm, life, change. There's a theory. Earth and Mars were born side by side in the same cradle. But one thrived, became alive. The other fell into silence and cold. What changed their paths? Perhaps Earth was lucky. Jupiter's gravity shielded it from asteroids, preserved its atmosphere. Mars, being smaller, couldn't hold on to its heat or its air. Its magnetic field collapsed, and life went with it. But maybe it wasn't just nature. What if Mars was interfered with? What if the catastrophe that turned it into a desert wasn't natural? Some theories even suggest that life on Earth is the result of Mars's downfall. That microbes or even technologies were transferred here by accident or design. It sounds like science fiction, but these ideas are being seriously studied. Because if Mars is Earth's fallen sibling, we must understand what killed it, and if the same fate could await us. Mars is silent. Not the silence of peace, but the silence of something long gone, something that perhaps once was, and then vanished. No birds, no wind through trees, no water trickling across stones. Only endless plains of dust, ancient craters, and winds that whisper across a dead world. But what if this silence is not simply absence? What if it is a message? We peer into the Martian void and see faint echoes of our own world. Dry valleys where rivers once may have flowed. Polar caps of ice that wax and wane with the seasons. A reddish sky that once may have seen clouds drifting across it. It's a world that, in so many ways, could have been Earth. It's as though Mars is a mirror not of what we are, but of what we could become. A warning preserved in dust and stone. What happened here? Why did everything stop? Scientists propose many answers. The loss of its magnetic field allowed the solar wind to strip away its atmosphere. Its small size meant it couldn't hold on to heat. A dramatic climate collapse may have turned lush terrain into barren desert. All of this, perhaps natural. But then come the anomalies. Structures too sharp to be coincidence. Magnetized rocks in patterns. Traces of isotopes, like xenon 129, that appear in ways we don't fully understand. They might be geological quirks, or they might be evidence of something more. Something or someone that was here and is no longer. And in this vast silence, one can't help but ask, is Mars what happens when a world is abandoned? Is this what's left behind after a civilization falls dust, silence, forgotten ruins? Or maybe Mars was never alive at all. Maybe it only pretends to resemble Earth, luring us in, testing our assumptions. But that, too, is a lesson. Because if a world that looks so much like ours could still be sterile, then intelligent life is even more rare, even more fragile than we imagined. And we are standing on a knife's edge, perhaps unaware of how easy it is to tip into silence ourselves. Mars doesn't speak, but its quiet is not empty. It is heavy. It is waiting. Waiting for us to listen, not with instruments, but with understanding. And perhaps what it's trying to say is simple. I was like you once. Be careful. Mars is silent, but we are not. Not anymore. For decades, we've looked at that red point in the sky and seen more than just rock and dust. We've seen potential, mystery, and perhaps even destiny. The time when Mars was just a myth or a backdrop for science fiction is over. Now, We send machines with eyes and hands. We drill, we sample, we listen. But more than that, we dream. Humanity is preparing to walk on Martian soil, not in a novel, not in a simulation, but in reality. This is no longer a story about curiosity. It is a test of who we are and who we want to be. We are reaching for a world that may once have known life, or may one day host it again because of us. But this mission isn't just about science. It's not just about exploration or glory. It's about survival. It's about meaning. Because if we go to Mars only to conquer it, exploit it, repeat the same mistakes we've made on Earth, then the red planet will become not a second home, but a second grave. A monument not to our greatness, but to our inability to learn. But if we go to Mars with humility, with respect for its silence and its unknowns, then perhaps something greater awaits. The act of touching another world is not just a technical achievement. It is a philosophical revolution. We are no longer bound to one world. We are no longer alone. But with that freedom comes a burden, to protect what we find and to preserve who we are. And maybe, just maybe, the silence of Mars has always been waiting for an answer. Not from a radio signal, not from a probe, but from us showing that we can grow, evolve, and carry the fire of life into the cold darkness beyond Earth. That moment is coming. And when it does, the red dust beneath our boots will mark the beginning of a new chapter not just in the story of Mars, but in the story of ourselves. Because in the end, the question isn't only, what happened to Mars? The real question is, what happens next to us?